Hello. If you're watching this, you missed day 2 of our Computer Science Principles class, semester 2. Let's get to it. So this class, really important. We're introducing traversals, which is a marriage between a loop and a list, both topics previously covered. So if you are a little shaky on either of those two building blocks, please make sure to come and see me, either after school or during Wednesday office hours, and I'd be happy to review those topics with you. We're going to also take a look at a sort. You're not quite expected to be able to write your own sort yet. It's a little bit more advanced, but I do want you to try to follow along and see if you can at least understand each part of what we will be doing. And then we're going to come back to this sort later on when we talk about something called algorithmic complexity, when it'll be very relevant. Lastly, we will start traversals practice, but we didn't quite get to that during class, so we're going to be doing that during class next time, and the assignment is going to be due probably next Wednesday, which is going to be the 10th. Let's take a look at traversals. So first we started with a quick warm-up, where I had you guys basically figure out the following. Given some list, if we add an element to the third spot, just secretly the fourth spot of this list, since there's a 0th spot, and something else to the 5th spot, and then print it out, what do we get? Well, you might think maybe we get 5, 10, 6, high, then there's a blank spot for the 4th index, since there's nothing there, and then sub, but actually, if you try to do this, you will get an error. The problem is, you cannot have a list in which you have a random hole in the center. That's not allowed. You cannot have that. Your list must be continuous. The first index, index 0, and whatever the length of the list, must have each place filled between the two of them. You cannot have a random spot there's nothing at. And that's going to be important for this thing we're about to look at, which is traversals. You cannot have a traversal through a list if there is some kind of blank spot in there. So, therefore, by default, your list cannot have this empty spot. So, traversals. What are they? Traversal is just a way to go through each element of a list and do whatever it is that you would like to do with it. Could be searching for a particular value. It could be tabulating them up into an average. It could be looking for something else. It all really depends on your application. Suppose we have this list. It has a bunch of numbers in it. Now I'd like to find the smallest number, or maybe a specific number inside that list. To do that, I'm going to need a loop. I'm going to be using a for loop to do this, although you certainly can use other loops. Recall that in a for loop, you have a variable you declare at the top here. You give it a name and a starting value. You tell it when to stop the loop. As soon as I is no longer less than 4, we stop. And then you increment the value by some amount or change it however you like. So I++ will increase it by 1, but you certainly could do something like I minus minus or I divided equals by 2, and so on and so forth. Now, ordinarily in class we would make this. However, it's not too difficult to understand without this manipulative. Essentially, we have a following structure. We have a for loop. Inside that for loop, we can refer to the variable I, since it sits within the scope of this loop. And I will keep track of how many times you've gone through the loop, but also you can use it to dereference a list. So this way, list at 0, then at 1, then at 2, then at 3, and so on, is what we'll end up looking at, and we can store that value inside element and then do whatever we like with it. This way, if we iterate from 0 to the length of the list, we get to see every single element from within that list. Pretty nifty. So, let's take a look at an example in action. Let's say we're looking through this list we saw in the beginning. Well, we start at temps at 0, since I starts at 0, and temps at 0 contains the value 77. So therefore, element will equal 77. Then we get to the end of our loop, and we start again. I increments by 1, so now we have 1 in both slots. Then we take a look at the first quote-unquote element, which is 85. So 85 is what's put into element. and so on and so forth. We get to see every single piece of this particular list. Now, once we get to the very last one in position number 3, then when we get to the end of the list, or the loop rather, our I is going to increment to 4. I hope you guys agree that 4 is not less than 4, which is the length of our list. Therefore, we exit the loop and we're done. So this is really powerful. You can use it for all sorts of things. Here's an example. For instance, we want to find out if 85 is in the list or not. We could say if element is equal to 85, then we know we found it. We could say, yay, we found it. Here's the index where I found it. And otherwise, we'll say it's not here. So if we were to run it on the previously shown list, you would get not here. Oh, we found it at index 1, and then 2 not here's. Another use is you could maybe look for the smallest element. So you would have to declare a separate variable called min somewhere up here, and you'd start it off equaling to just the first element in your array. Then as we go along, we see if the element we're currently looking at is smaller than the minimum we currently hold. If that's the case, that's our new minimum. So say minimum is equal to element. You could do the same thing to find the maximum. The only thing that would change would be instead of element less than min, we would switch it to be larger than max. Otherwise, the structure is exactly the same. Lastly, of course, if you're working with words, you wouldn't be comparing things, but you could do something like substring to get a particular letter and see if your word starts with a letter that you're looking for. And you can always compare two strings as well. So you can look for a specific word like yes or no or confirm are usually useful. Now, this next section I'm about to show you is very, very difficult. So if you don't follow it fully, that's okay. We will be coming back to it later in the year. But I wanted to show it to you now because it does feature two traversals, which is what we're talking about. Something you might want to do to a list is you might want to sort it. Not just look for something, but actually rearrange all the elements so they're in a particular order that would make it a lot easier to find things in the future. Kind of like a phone book is alphabetized. We're going to take our list and alphabetize it. How do we do that? Let's say we want to do it in ascending order. So starting from the smallest element and building up to the largest element. Well, let's start with what we already know. We can find the smallest element using the code below. We already saw this. We start minimum as a really large number, or we could start it potentially as the first element of our list if we like, it doesn't matter. Then for each element in the list, if what we're looking at is smaller than the minimum, set the minimum to that new amount. Sounds good. Now what? Well, the next logical thing to do might be to take that element and move it to the front of our list, right? That way we have the smallest element at the beginning, which is really what we want. So let's do that. In order to do this effectively, we need to keep track of where the smallest element is in our array. We can't just remember what the actual value of it is. We also need to keep track of where it is. To do this, I created a brand new variable called key. I started it at list.length, so outside of the scope of our array. And then as I go, whenever I find the new smallest number, I set the key equal to I, thereby remembering the index at which this particular value is located. Now, how do we actually put that value in the beginning? Well, I'm going to make a temporary variable to hold whatever it was in the list's first position originally. That way we don't lose any information. Then once I've stored that, I'm going to put the smallest thing we found, which is located at myList@key, into myList@0, thereby moving it to the very beginning of our list. And lastly, I'm going to take the extra value that used to reside in the first slot, and I'm going to put it into wherever we found the smallest thing. That way our array still contains all of its elements. We didn't lose anything. Everything is still there for us. Now we're not quite done. We've just moved the first smallest number over. Now we need to put every other larger number next. So how do we do that? We need to continually find the smallest leftover number and put it to the front, but not the very, very front, just whatever the unsorted section of our list is. So how do we do that? We're going to need an extra loop. This is going to be a nested loop. So what that means is we have a loop inside of a loop. Now, I went ahead and made this using the variable j. So we have two counting variables. The inner one is called I, and the outer one is called j. J is going to go through the entire list, and as we go, we're going to find the smallest value, and we're going to put that smallest value into the jth slot. So instead of always going to the first slot, we're going to go first to the first slot, then the second, then the third, then the fourth, then the fifth, and so on. So that makes a lot of sense. But there's still one problem. This inner loop looks through the entire list. If you look through the entire list every time, we'll always find that really small value we already moved to the front. We don't want to keep moving that value. We want to leave that value alone. So in order to do that, when we first start I, we don't want to start it at 0. Rather, instead, we want to start it at whatever place our unsorted section of the array starts at, which is going to be j. So j is going to keep track of where we've sorted to inside the array. I is going to keep track of finding the smallest value in the leftover array, the part we haven't sorted yet. So take some time to stare at this and try to understand it. If you would like more help getting to the bottom of how this works, you can always take a look at this code here, which is linked to you to code.org. You can view the code and then try running it and see if that makes sense to you. You can play around with changing this list and seeing how the sorting happens. I display each step as we go through to sort. And ultimately, as you can tell, we do end up with a fully sorted list. So this does work. We call this a selection sort because we're selecting the smallest value and moving it to the front each time. Hopefully this is not too crazy for you. We will be continuing covering traversals next time in class. And if you have any questions, please feel free to email me. Thank you very much, and I'll see you later.